Would you like to learn about cloud load balancing, DNS load balancing, and virtually every other type of load balancing you'll see in a cloud architecture or a data center architecture? If so, this video is for you. In this video, we're going to talk about all the types of load balancing. We will cover what is load balancing. We will talk about the types of load balancing. We will get involved in how load balancers work and even talk about the load balancing algorithms to a degree. But I mean, we're going to cover every kind of load balancing: cloud load balancing, DNS load balancing, storage load balancing, network load balancing, even CPU, DRAM, and GPU load balancing, because it's really the fundamentals of load balancing. And if you understand one of these types of load balancing, you'll understand them all, because I want to show you how they all operate and how they're all so similar. So by the time you're done this video, you'll know all the types of load balancing, from AWS load balancing, Azure load balancing, cloud load balancing, DNS load balancing. I mean everything. But what I'm going to do is I'm going to walk through some architectural examples. And the first thing I really want to talk about is really what is load balancing. And load balancing is just a means of sharing the load across multiple devices. So if you had one person rowing a boat, they could only row at a certain speed. But if you had 10 people rowing that boat, and all of them were doing it at the same time in the same direction, now that boat's going to move a lot faster. And that's all load balancing is. It's going to be a method to increase performance, as a general rule, and to increase the availability of the systems. Because if you have 10 rowers in a boat and one of them gets tired, the other 9 people can still run. And that's what we're going to be talking about. So let me now bring you into an environment where I can start showing you the architecture of how this would work. And I'll start by showing, say, cloud load balancing, and then we'll walk through all of the types of load balancing. So in this first type of load balancing, what we're going to be dealing with is DNS-based or cloud load balancing. Perhaps we have some systems in our data center, perhaps we have some systems in AWS, and perhaps we have some systems in Azure. And let's say these systems are web-facing. With DNS load balancing, we could basically say any of these policies we want. For example, we could say send 50% of the traffic to the data center, and send 25% of the traffic to AWS and another 25% to Azure. No big deal. We could also say send 80% of the traffic to the data center, or even 100% of the traffic to the data center. And if we reach a certain level of latency, level of performance, start scaling out or adding capacity to AWS or Azure to make up for the lack of capacity. It's called cloud bursting. There's a little more that goes into it than what we're describing here, but that's one of the possibilities. Now, in order for any kind of load balancing to work, we're going to have two things that are going on. One is we're going to have something that's listening. So obviously the DNS servers are listening for you to type www.gocloudcareers.com. They're listening, and if you do, then they would determine where you would send that web server, for example, to our data centers or to a cloud on Cloudflare that we might be, or AWS. So that is one type of DNS. It's listening for the DNS request. But DNS also needs to know something else, and all load balancing will need to know this next thing. They need to know that there's a recipient for where they send their traffic or where they send their data. So how would DNS know if the data center is there, or if AWS is there, or Azure is there? It can't just assume. So what'll happen is the DNS servers will ultimately send some form of a health check to each one of these environments. It'll essentially be saying, data center, are you there? And the data center will respond with a message that says, yes, I'm here. And then at the same time, the DNS servers will query AWS, are you there? And if AWS responds, yes, I'm here, everything's good. Same thing would occur. This is your typical DNS health check, your load balancer health check, your routing protocol health check. It doesn't matter. So DNS is going to send a message to Azure, you're there, and Azure responds. Now let's say DNS sends a message to, say, the data center, are you there? And the data center doesn't respond. And let's say DNS sends another message to the data center, are you there? And the data center doesn't respond. And then DNS sends another message to the data center, are you there? And the data center doesn't respond. Depending upon the way this has been set up, what will usually occur is this data center will be marked as unhealthy. So once it's marked as unhealthy, DNS will know, do not send traffic to this unhealthy thing. And then it will shift all traffic to AWS and Azure. Now, if you really think about this, if we had 50% of the capacity running in the data center and 25% in AWS and 25% in Azure, and Azure and AWS both have auto scaling on the web servers that are there, or the containers that are serving the web, whatever you choose to use, either one of those can add capacity. And inside of a few minutes, at that point, like 20 minutes or so, because there's not that much capacity they have to scale, all of a sudden they're up at full capacity in 2 different clouds. So it's one way we can increase availability and performance. So that's DNS-based load balancing, but I want to show you that all the other kinds of load balancers that we'll be using. So let's say we go to our cloud VPC, we go to our cloud VNet. I promise you there's going to be a lot of load balancing that we're going to be using, and we're going to walk through each and every type. Now, typically speaking, if you had a web-facing server or something you needed to secure, you're typically going to have some next-generation firewalls. Now, your cloud providers typically don't provide firewalls by themselves at this level of sophistication, so you'll typically use a couple of enterprise-grade next-generation firewalls as part of your security architecture. Now, in the cloud, these next-generation firewalls are going to be virtual machines, and since virtual machines are not high-availability devices, you'll typically use a network load balancer in front of your next-generation firewalls. It could be a network load balancer. AWS has a term also called gateway load balancer you could use here, or you could use a network load balancer. But whatever the point is, you'll typically use network load balancers to load balance like with a network appliance like a next generation firewall. Now, we're also going to have load balancers to load balance between our virtual machine. One virtual machine, if it dies, we've got nothing. So we might use 3 or 4 smaller virtual machines. And it might be cheaper to use 3 or 4 smaller virtual machines than one big virtual machine. So we will use some form of a load balancer to load balance between these virtual machines. Now, if these were big, giant virtual machines with, say, 128 cores, we'd use a network load balancer to load balance with these things, because network load balancers are fast, because they don't do a lot. They don't have to think a lot. By comparison, if this was all smartphone virtual machines, we might use an application load balancer to load balance them. But either case, it's still load balancing. Now, we might have a load balancer that we're using to load balance between our containers. Typically, it's an application load balancer, but we could use any type of load balancer we would need to load balance in between containers. It's another form of load balancing you'll use, but they all do the same thing. You may have an API gateway that's load balancing between microservices. And at the end of the day, and we'll walk through a walkthrough of more load balancers and how they work, it's all the same technology. The load is just going to be shared. So in this particular case, for example, we want to share the load between the virtual machines. So the load balancer will send, I'll move this up just to some of the load to virtual machine 1, then some of the load to virtual machine 2, and then some of the load to virtual machine 3, and some of the load to virtual machine 4, and it'll go back and forth, keeping these servers' loads fairly well distributed. Now, there are a few number of load balancer algorithms we'll talk about in the end, so you can see how they can actually distribute load, because there's different algorithms that you would use for different situations, but at least understand it's load balancing. Now, if the load balancer was load balancing between containers, it would be doing the same thing. If the load balancer was load balancing and routing between microservices, it would be doing the same thing. So that's one type of load balancing. Now, let's get inside the servers, inside of the storage. And I want to show you another type of load balancing. This type of load balancing is called RAID. For example, if we were going to use RAID 0, which is just disk driving, what we would typically do is we'd have a RAID card or a RAID controller of some form, and it would say, write 1 block of data to disk 1, 1 block of data to disk 2, 1 block of data to disk 3, 1 block of data to disk 4, 1 block of data to disk 5, and 1 block of data to disk 6. And this would go on. So if we have 6 drives and each drive is 4 terabytes, by having 6 of them, we'd have 24 total terabytes. At the same time, if each one of these NVMe drives is about 4,000 megabit per second, with 6 of these, we can get 24,000 megabit a second. So we can get a lot of performance out of this. Now, at the same time, we could also create a redundancy strategy by using something like RAID 5, where we would write to basically 5 out of the 6 disks and put parity data on each disk. So if we ever lost a disk, we'd have enough. We could take a disk out, pop a brand new disk in, and rebuild the data from all the backup or parity data. So again, it's just load balancing. So the storage in our servers is going to be load balanced. Now, if we think of block storage in a cloud computing environment, If we think about even connecting to the cloud, again, there's going to be much more load balancing. So now let's look at your typical storage area network, the kind of block storage you would have in, say, your cloud provider or your data center. And what do you really have? So ultimately, you're going to have these giant boxes. And these giant boxes that we actually have here are going to be filled with hard drives. And what's going to occur is there's RAID controllers on these environments, and they're going to be load sharing amongst all these disks inside of the storage area network. Now, what we'll typically do is we'll have something called these storage area networks will be plugged into the enterprise network. So if we say this, what we might do here is we might bundle multiple links together. Now, what do I mean by bundle multiple links together? So this is something called the link aggregation group in networking, where let's say each one of these links was 10 gigs. We could have one 10 gig link, the second 10 gig link, the third 10 gig link, and the fourth 10 gig link. And we could bundle them into something called the link aggregation group. And that's a means of load sharing and load balancing across these links. Now, if we look at a link aggregation group, guess what we get? We lose one link, we still have three others. So just like the load balancers, what we're dealing with is we're improving performance and availability and resiliency in the system. Now, this is, realistically speaking, inside of just getting the inside of the storage network that you'll typically see at your cloud provider. But how about on the server? Do we have any load balancing in the server? Well, let's kind of talk about what goes on in the servers that are going to power the virtual machines that you're actually using in your cloud computing environment. Well, you'll note there's typically 2 or more CPUs that you'll see in a server, and each one of these servers has 64 cores. I'm not going to get into hyper-threading here, but let's basically say all we were going to do was load share across these 64 cores. So that means, if we were only going to use one CPU core, then we'd lose the other 127. So what'll happen is the operating system or something will schedule where the tasks will run. Run on this CPU core, 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 run on this CPU core. And by doing so, the load would be shared across these 128 physical cores that are sitting inside the server. Now, you may also notice that the server is going to have these little banks of DRAM on the motherboard, and there will be these physical DRAM chips that are placed inside that motherboard. And of course, the load is going to be shared across all these DRAM chips. Again, just another type of load balancing. Now, if we actually look into the server, let's say this server is going to be used for AI. This is a heavy-duty GPU compute server, and note that you'll see a fair number of graphics processors that are actually plugged into the PCI interface. Now, again, the CPUs and other things will start scheduling tasks across these GPUs in a matter to load share. So you'll see load sharing across graphics processors. This may enable pooling of memory with things like NVLink that could be used, for example, with NVIDIA GPUs, or at least certain kinds of GPUs. It'll increase the compute power. So what you're saying is this is load sharing too. And it's load sharing in the device. And I'm going to walk you through another kind of load sharing. And in this kind of load sharing, we're going to talk about connecting to the cloud provider. And that's going to be another form of load sharing. So let me steal these two. Let me steal this networking link that I made here because I like the way it looks. And let's add this over here. So here what you're going to see is we've got a link aggregation group. This is 10 gigs, this is 10 gigs, this is 10 gigs, and this is 10 gigs. And we're going to have 2 of them because this is going to be a high availability environment that we'd say connect to a cloud provider. So and let's say this is, here's the cloud provider over here. Now, if we had these private lines, and the private lines go from our campus or our data center to the cloud provider, you're going to notice 2 things. One is we will never buy these links all from the same company. So if we buy these 4 links, for example, from, say, AT&T or Verizon or BT or Etisalat or any company that's local to us, it doesn't really matter. We're going to buy these 4 links from another company. Because we're never going to put all our eggs in one basket. We can never put all of our networking systems in the same provider, because if the provider has an outage, we lose everything. So if this is, say, AT&T in America, this might be Verizon. So all these 10 gigs will link. So what I want you to see is two things. One is we're going to be load sharing across these links in a link aggregation group. Now, the switches and routers will do that automatically once you put them in a link aggregation group. That gets simple. But what I want you to also notice is we have two link aggregation groups. We've got a top link aggregation group, and we've got a bottom link aggregation group. Now, how do we determine whether we use just the top or whether we use the bottom? Well, what'll happen is through BGP, you'll determine a routing path whether you wanted to use the top link and the bottom link. But the point is the routers will load share across these links and across the top link and the bottom link if you tell them. So why did I walk through each and every one of these kinds of load balancing? I did it because I wanted you to understand they're all effectively the same. And if you're dealing with something on the routers, something on the switches, something in the storage, something in the server, something with containers, something between microservice and virtual machines, it's almost all the same. And if you truly understand the fundamentals of load balancing, it's very easy. So now let me walk through just a final thing on load balancers to make sure that you understand them as well as all the algorithms. We'll have some fun with this, and then we'll summarize. So if we go back to this environment, let's go back to to a load balancer and how it works. I want to make sure everybody just gets this in the end, and we'll talk about certain types of algorithms while we're at it. So if we have our load balancer, ultimately what we're trying to load balance is something, and it really doesn't matter what it is, so I'm just going to call it a target. And some of the cloud providers use terms like targets in their load balancing as well, but I think it's really just a good term here. So we've got the load balancer, and again, this load balancer is determining are the devices there with a health check, just like we talked about before, and assuming they are, they're going to load balance between the devices. Now, there's a lot of ways these load balancings can actually occur. So there's something called round robin, where a load balancer could say, hey, I'll load balance to equal parts this one, this one, this one. Send the first session here, the second session here, the third session here. And that's typically called round robin. It's a very common algorithm. Now, you can actually do something called a weighted round robin environment. And in this case, you could say that this server is bigger than these two other servers. So send 50% of the traffic here and 25% to each one of these servers. And that's a weighted round robin algorithm that you may see. Now, you may also see a load balancer use what's called least connections. And what the load balancer is doing is it's tracking the active connections on each one of these. The number of network connections, say TCP connections, or other types of connections that are on that server. So when it sees that this server has 100 connections and this one has 200 and this one has 5 connections, for example, it sends the session to this target. And that's typically your least connections. Now, of course, with anything else, you can do a weighted version of that as well. So you can make it choose the server with the fewest connections relative to its capacity, if you had a higher capacity server with, say, more cores. Now, other ways that you typically can do this from an algorithm perspective is you can do least response time. So they can look at the amount of time it takes to connect to a server and have it respond, the total latency of the situation, and say, lowest latency, I'll send it here. So they're your major load balancer algorithms. There's a few more, but that's typically what we're dealing with. So basically speaking, load balancing is everywhere. You'll use it everywhere, and they all work almost the same. So I hope we enhance your experience of cloud load balancing, DNS load balancing, what is load balancing, the type of load balancing, Azure load balancing, AWS load balancing, and hopefully every other kind. If you want to become a cloud architect, security architect, AI architect, enterprise architect, join me in a free webinar. We hold one every single week. We'll go over the architectural role. We'll talk about what we do on the skills that you need, and we'll answer any questions because it's live and free on Zoom. You can sign up for those free webinars in the description of this video. We also have programs to help you become a cloud architect, enterprise architect, security architect, if that's your goal as well. I also wanted to say that if you enjoyed this video, please give it a like, maybe subscribe to our channel and hit the bell to be notified of new videos to assist you in your technology career. At Go Cloud Careers, we specialize in cloud architect, enterprise architect, security architect, AI architect, and network architecture careers. This is Mike Gibbs signing off for now, and I hope to see you in another video. Take care.